All right, let's look at the homework 14.7, problem number 3. All right, so we have f of x comma y equals 5 sine of x and sine of y. We want to find the critical points and determine if they give us a local max or a local min or a saddle point. All right, so let's do that. All right, so first we have to take the partial derivative of f with respect to x. All right, so this is going to be, all right, 5 just a number. All right, so derivative of sine is cosine, so it's a cosine of x. All right, then sine of y just a number, so I'll just keep it as it is. All right, so we want to set that equal to 0. All right, so in order to make a cosine of x equal to 0, right, so we want to, let's say, so we need to make x either plus or minus. X is going to be either plus or minus pi over 2, right? Or we can make a sine of y equal to 0, so that will give us either y is equal to 0, right? Then if you look at the partial with respect to y, then you will get 5, right? Sine of x is just a constant, so I'll leave it there. Right? Derivative, partial derivative of sine of y with respect to y is cosine of y, right? So we set that equal to 0, right? So here, sine of x, so x is equal to either 0 or cosine of y. We can make cosine of y equal to 0. So y is equal to and plus or minus pi over 2. All right. So we have to do that. So how many critical points can we find from here? All right. So critical points. All right. First one, 1. All right, so let's say we can do, x equals pi over 2. So here, actually, let's see, x equals pi over 2, right? Then y has to be pi over 2 or negative pi over 2. So you're going to have, so I'm going to do a positive pi over 2, right? And the second, the critical point would be, let's still do a positive pi over 2. Then we have to make sure that the y is going to be equal to negative pi over 2. Right? And the third one, we can do a negative pi over 2 for x. And the y has to be either positive or negative, so you're going to have a pi over 2. Or fourth one. So fourth one would be negative pi over 2 and a negative pi over 2. All right, other one would be we can take y to be 0. All right. Then x has to be 0 too. So we have that. All right, so we have 5 critical points. So we have a critical points there. All right, then we just have to do the, second derivative test. So I'm going to find second partial with respect to x. All right, this would be, it's still 5. And derivative cosine is negative sine of x, and then you have a sine of y, right? And second partial with respect to y is going to be, all right, so we take the partial, so it's going to be negative 5 sine of x. This is just going to be a number. And derivative of cosine is negative sign, so I already put the negative there. So you have a sine of y, right? And then mixed partial. So f(x) of xy. So this is going to be, so we take the derivative of that with respect to y. So it's going to be 5 cosine of x. It's just going to be a number. Derivative sign is cosine of y. Right, so we have that. So d is going to be, right, so d of x comma y is going to be, alright, so -5, so it's a 25. Alright, then you have sine of x, sine of x, sine of y, so you have a sine squared of x times sine squared of y minus squared of that. So you're going to have 25, right, cosine squared of x and a cosine squared of y, right? So we got that. All right, so let's check all critical points. So first one, let's find d. Right, so d is going to be, right, pi over 2 and a pi over 2. Alright, so pi over 2, you can see that the sine of pi over 2 is, Alright, sine of pi over 2 would be 1, so this is going to be actually 25. And a cosine of pi over 2 is 0, so that's just going to be 25. So this is going to be positive. So we're going to look at the second partial with respect to x at pi over 2, comma pi over 2. Right, so second partial with respect to x is that, so you have pi over 2. So sine of pi over 2 is 1, sine of pi over 2 is 1. So this is going to be actually -5, right, which is negative, right? So it tells you that the bowl is facing down, right? So we know that this is going to actually give us a local maximum. Right, so let's do the second critical point. Right, so d is going to be, alright, so pi over 2 comma negative pi over 2. Right, so this is going to be, alright, so if you plug in pi over 2 and a negative pi over 2, cosine of pi over 2 is 1, sine of negative pi over 2 is -1. So it's going to be, let's see, but it gets squared anyway, so it's going to be 25. And the cosine of pi over 2 is 0, and the cosine of negative pi over 2 is also 0 too. So it's actually, again, it's going to be positive. And if you look at the second partial with respect to x at pi over 2 comma negative pi over 2. Right, so this is going to be, right, second partial. So you have a -5, right? So -5. And then sine of pi over 2 is 1. And the sine of negative pi over 2 is -1. So it's actually positive. So it's going to be a bowl facing up. So we know that it's going to give you a local minimum. Right? Alright, third point. Alright, so you're going to have d of negative pi over 2 comma pi over 2. Alright, again, when you look at that, d sine squared sine squared of y, so pi over 2 in there is going to be 1, so it's going to be 25. And cosine of pi over 2 or negative pi over 2 is 0, so it's still going to be positive. And if you look at the second partial with respect to x at the negative pi over 2 comma pi over 2. So this is going to give us, all right, negative 5 there. All right, so you have a negative pi over 2 makes sign negative, so it's going to be positive. And a sign of pi over 2 is going to be positive 1. So this is positive, right? So which means that we're going to have, again, local minimum. All right, and the fourth one is we look at the d of negative pi over 2, comma, negative pi over 2. And again, this is going to be 25, so it's going to be positive. All right, then we're going to get, let's see, partial with respect to second partial with respect to x, evaluated at the negative pi over 2, comma, negative pi over 2. All right, so you can see that it's going to be negative 5. Then you have a negative 1, negative 1 times negative 1, so it's going to be negative. Right, so if it's negative, which means that you have a ball facing down, so we have local maximum. All right, then last one is the origin. So if you look at the d of 0, comma 0, so this is going to be, right, if you put 0, sine of 0 is 0, so it's a 0 minus 25, cosine of 0 is 1, so you have a 25. All right, so this is negative, which means that this is going to give us a saddle point. All right, so let's see. So when you have, let's see, different signs, then we're going to have a local minimum. And we have the positive, positive, or negative, negative. You're going to get the local maximum. So let's type it in. All right, so maximum value. So when we have the same sign, so we have, say, pi over 2, comma, pi over 2. Or negative pi over 2, comma, negative pi over 2. And you get a maximum. Minimum when you have different signs. So it's a negative pi over 2, comma, positive pi over 2. Or positive pi over 2, comma, negative pi over 2, right? And the saddle point is the origin, at the origin, right? So let's check the answer. Submit for testing. All right, I didn't read the question. We want to find the local maximum value, so we actually have to plug those guys in. So you have a sine of pi over 2 is 1 and 1, so it's going to be 5. So instead of giving the critical numbers, I have to actually give, if you plug those points in, actually both of them actually gives you maximum of 5. If you plug in negative pi over 2, so that's going to be negative 1. Positive pi over 2 is positive 1. So we're going to have negative 5. So we have, right, negative 5. Right, then here and saddle points, it's I put the x value and y value, but we'll have to put the f value. So we plug in 0 and 0, so it's going to be actually 0 again. So it's a 0, 0, 0. All right, so let's check the answer. Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.